So, yeah, very happy to be here. Thanks for having me. I'm Jonathan. I work in the technology division at Goldman Sachs. I know that right now I'm literally standing between you and the drinks. So I know that's a hard position to be in, so I'm going to try and make this as interesting as possible. So what I'm going to talk about during this presentation is our journey with RabbitMQ within Goldman Sachs as a firm, and how we initially picked up RabbitMQ as a product and why we did so. How did we build an internal offering, and how developers interact with RabbitMQ as a product within the firm, and how do we deploy RabbitMQ, and how do we manage it? Just to give a bit of context. So I run the messaging engineering team at Goldman Sachs. So I know that not many companies necessarily have a dedicated messaging team. A lot of companies, it's application teams actually running their own broker or their own solution, and they sort of fine-tune it to their use case, and they fly and they're happy with it. But at Goldman Sachs, we operate things at a scale that is big enough that justify having a team of dedicated messaging engineers. And so what we do is we provide messaging infrastructure services for applications across the firm. And so we engineer a number of different messaging products, and we serve them as a platform, and we make them easy to use for application developers, at least as easy as we can. So as I said, yeah, we run products as services, as a platform. And so over the years, we built a portfolio of products to accommodate various use cases. So across the bank, we provide services for various divisions. It could be trading divisions, risk divisions, banking divisions, and they all have very, very different use cases and different kind of payloads and different requirements. We can get into really high volume sort of workloads with really little value attached to a message, so high volume and low value. Or the extreme opposite, you can have very low volume but very high value associated with the message. What if I told you we have messages going through infrastructure that are worth a couple $1 million? You probably don't want to lose that information. And so because there's no one size fits all, no one product, we built a portfolio of those, and we accommodate a myriad of use cases from log shipping to telemetry, metrics, all the way to trade booking or payments, external payments, regulatory flows as well, because we're regulated institutions, so we need to talk with our regulators. So yeah, a number of things, and a number of application teams that we host messaging products for. So to go back how we picked RabbitMQ, we'll go back in time a little bit and go through the history of what we used to have, what we used to provide a service, what we still do in some cases. So back in 2013, 5 years ago, we really were leveraging two big families of products. Reliable multicast messaging, that's your find, forget, fire hose. So if you've dealt with any messaging engineer in the past, you'll know that we don't use reliable as everyone else. Reliable means I trust that the network is reliable. The network should do its job, and I'm not really going to try and put any kind of guarantees around this. And so this is really a use case where it's a row, find, forget. You want to push as much data as fast as possible with a high degree of fan-out, so one publisher and many subscribers. You don't necessarily care if you're losing a couple messages here and there, but you just want to know that you've got the latest data as fast as possible. Great for streaming prices and life-taking data like stocks, for example. And at the other end of the spectrum, you had the good old GMS brokers for granted messaging. So this is your rock-solid messaging where you most of the time rely on XA transactions with two-phase commits. Sometimes you have, let's say, a database upstream and a messaging broker downstream, or the other way around, and you want to do a transaction where you know that it's all or nothing. I want either everything to happen or nothing at all. And most of the time, we would use this underpinned by synchronous storage replication. So that's your block storage arrays, and we would have synchronous replication across data centers so that we would know that for sure, 100%, the data would be available in two different data centers for business continuity purposes. So, we were thinking, okay, we have to do two big things, but it's a bit like going to the ice cream shop and you only have two flavors. Okay, vanilla and chocolate are fine, but could we have something in between? And so that's actually an internal slide from GS that I'm leaking today. that from a presentation that I gave 5 years ago, why do we need something new? Well, not everyone needs guaranteed messaging. For the longest time, GMS brokers were the only show in town. If you want to have a queue or a topic and you want to have queue semantics, and there's a lot of use cases that we were seeing using GMS brokers were really that they didn't really need that. And hardware-based guaranteed messaging is costly and not flexible. It's most of the time relying on bare metal hosts, costly block storage arrays, costly replication. It is fairly slow. And lastly, we also wanted to dive into open protocols and to get into a situation where we're much more relying on a protocol and on an API rather than specific implementation of a broker. So, as I said, two big families: reliable delivery, guaranteed delivery. But we wanted to have a bit extra. We wanted to have something that was sitting in the middle. And we internally coined it as resilient messaging. That's your good for everyday messaging, your good enough messaging, or as I think RabbitMQ used as a mantra a couple of years ago, maybe still the messaging that just works. So we came across a couple of products, we evaluated a couple of products, and we settled on RabbitMQ. Why? So I think the most important thing initially was to have something highly available. So our GMS broker solution were just a single broker, and should the broker fail, then we would do storage failover, and it would take a while for a secondary broker to come back up. So not really highly available. We wanted a cluster solution where losing a node should be really a non-event. We wanted to have more messaging patterns. What if I just, I want to have something more than a simple 1-1 queue semantic. Maybe I want to have last value cache. Maybe I want to do some kind of routing. And there's been a lot of discussion today around how flexible RabbitMQ can be. And this is what we really wanted to benefit from. We wanted developers to be able to use our infrastructure with any fancy or whatever the latest, the hypest language was. Wanted to be able to leverage multiple language bindings. And last but not least, when you run things at scale, something RabbitMQ is really good at is it's really easy to observe and easy to manage. So you know what's happening, and there's a lot of APIs that are exposed either to collect metrics or to configure the Rabbit brokers. So there we knew that we wanted to use Rabbit, but how? Because there's many flavors of using RabbitMQ. I think today we've seen a good selection of that. And this is how we got into the hard part in terms of modeling and usability. How do you build an offering? How do you build something that developers want to use? Because again, RabbitMQ is an open source product, so nothing prevents our developers from just going, downloading RabbitMQ and running their own brokers and clusters. And sometimes they still do. Well, they usually come back crawling to us after. But you want to have developers use something because they like it, because it's easy and it's nicely modeled. Sadly, there's most of the time no one size fits all. You can do a lot of different things with Rabbit. I wish we had a solution that fits every single use case perfectly, but that doesn't exist. I think we've got some really good slides today around this. But you can still try to have a template that you can leverage. Something where, okay, it's not going to fit every single person, but what if I can get to the 80% use case? What if I can get 80% coverage, where most of the time you can deploy a broker, you can deploy a cluster, and developers will just be happy, and everything is going to work for them. And so this is how we progressively got into a standard deployment model. That's the way we deploy RabbitMQ by default at Goldman Sachs. I'm not saying that this is the way you should deploy it. May work, may not work for you. We run 3 nodes cluster. We front them by DNS run robin. So when they resolve the DNS health that they're being given for a cluster, it resolves to one node in run robin fashion. They can connect to any nodes. We usually don't collocate applications in clusters. It's one cluster per application. If applications want to collocate, that's because they're usually part of the same area or the same business. They've got the same kind of business constraints. It's not that RabbitMQ can't scale, but it's most of the time for us a business isolation constraints. And we let developers choose and have that flexibility. We're not ones to dictate, like this area should be using the same cluster. We'll leverage MQP 091. I'll explain why later. And our bias is consistency. So there's, as we've seen today, there's a lot of ways you can use Rabbit. But from our standpoint, we've got a strong bias and consistency across nodes. So we run partition handling as pose minority, so that the contents of messages in the cluster don't diverge across nodes. A node that is being isolated is going to post itself, and the clients are then going to fail over to nodes that are still serving requests. And we use mirrored queues by default with automatic synchronization by default. At which point people, ooh, it's by default, it's bad, it's slow, and etc. Well, yes, it is slow, but from our standpoint, I would much rather have an application developers come to our team and say, hey, you know what, your thing, it's great, but it's a little slow. And then we have a discussion about relaxing the constraints. And then we can fine-tune and have a discussion with them and make things better. But I would much rather have this than having an application team that comes to us and said, where we relax the constraint by default, and then they come to us and say, well, we actually have lost data. That's a much of a tougher sell. So let's talk about usability a little bit. So we deploy 3 nodes clusters, but really what we wanted this offering to be compared to the other products that we were leveraging, we wanted to have something really flexible, something where developers would be in charge of what they were using. And using MQP 091 and most of the bindings, you can programmatically define your topology. And that's really powerful because it means that a developer, over time, you can adjust your topology, your queues, exchanges to fit your business requirements. A lot of other offerings and products that we had, we were actually, as an engineering team, as a messaging team, involved in a lot of changes. Oh, can you create me that queue? Can we add more of this, more of that? And this is something that we really don't want to be in the loop for. We're not the experts to decide that, oh, this is, you should have, you should read your data this way or that way. Actually, giving credit where it's due, that's a screenshot from the RabbitMQ visualizer. It's a really good website where you can design your topology with routing, exchange, binding keys, and etc. And then you can simulate where the payload would go. And it's really useful to see how data would flow so that you actually don't have to write any code. You can literally just design your own topology beforehand. So the way we deploy clusters, those are really an empty shell. We give you a cluster, we give you a DNS alias, maybe some permissions associated with it. I'll come back to that later. And then as a developer owning an application, you're really in charge. It's up to you to maintain your topology, so it gives you a lot of flexibility. But on the other side of the coin, it also means that as infrastructure engineers, we expect developers and applications to be able to reconstruct the topology from scratch. That means that if any of you in a room were to use one of our internal clusters, and then you start using it, you configure it, all goes well, and then if I decided to replace your cluster completely with the same kind of configuration in terms of permissions and number of nodes and etc., barring that you wouldn't be happy about losing data, then if I give you a blank cluster, then you should be able to reconstruct the topology from scratch, everything, exchange, bindings, queues, and etc. That's great because it gives you reproducibility. You know that this is how the application is designed. This is how producers and consumers are supposed to interact. And this forces you to define your contract really well. If you go around and you go in the management interface and you create queues and exchanges manually, then this is just point and click, and you're not really spending time thinking and designing and sort of engraving in stone, for lack of a better expression, how your application should interact. And so how do we do that? So there's been a lot of time that has been spent, a lot of discussions that were had in terms of namespacing and how do we model a topology for applications. And so we introduced a concept called message domain. And so there's a couple of things. So a message domain is tied to a virtual host, comes with a prefix for queues and exchanges. So if I give you a prefix a.star, you'll be able to create any resource, MQP resource in that domain. The mirroring and queue synchronization mode, again, those are enabled by default, and automatic synchronization by default, but we can change it after the fact. And for each domain, there's a list of untitled users. And those untitled users are modeled and backed by an inventory where we can know, okay, application A, application B from equities trading or risk management actually owns that topology and is entitled to it. A given user can access one or multiple domains. The domain access is read, write, or configure. Nothing new here. Those are the RabbitMQ permissions. And we leverage regular expressions. So let's say I've got a log processing applications, and I'm publishing messages with the running key, warnings.blah and errors.blah. Maybe I've got specific consumers that are specialized just for warnings, just for errors. But maybe I've got a consuming application that wants to read all of that. And then they'll have access to two domains, the warnings domain and the errors domain. And so they might just have read and configure rights to it. You still need configure because you need to bind the queue to the exchange. And then the underlying RabbitMQ permission would be warnings.star, pipe for the logical OR operator, errors.star. And so we can actually chain domains like that. So I went through a rough deployment model. How do we model it? How do we model topologies? But adopting RabbitMQ for Goldman Sachs was quite a drastic change. Because first, it was the first open source messaging broker and solution that we were leveraging overall. But it was also a change of paradigm into how applications interact with the messaging layer. Remember, a lot of applications were used to super fast fire and forget, where I can send like loads and loads of data, and the only thing that matters is how fast my network card can be. Or traditional quarantine messaging, where there was not so much to know about. It was just send a message, do a transaction, wait for the blocking call to return, and that's it. Whereas when you use RabbitMQ, there's a lot of other things that you need to be aware of. And this is how we actually needed to do a lot of discussing and consulting and hand-holding with applications so that they could understand how you were supposed to talk to RabbitMQ and how to use it. Overall, I think the takeaway is, on average, you have to write smarter applications. You need to listen to what the broker has to tell you. You need to understand the feedback you're getting from the cluster. Duplicates can happen. Idempotent consumers, you need to have some kind of sequencing GUID, or you can have a look at some of the tags in the message. That might, in today's world, that sounds, a lot of solutions are at least once, and we're expected to handle with duplicates. But at the time, I still vividly remember my first few discussions with application teams, and we'd literally go, well, what do you mean 2 times the same message? Like, I have to do something in my callback? Yes, you do. And progressively, applications learned that. Some of them the hard way. Overall, there was no more one blocking call and you're done. No more, I call SEN, it's a blocking call. When the call returns, I know my data is in 2 different data centers. I know my data is safe, and etc. You need to embrace the asynchronous nature of the design. Be it on the consumer side, where you can acknowledge asynchronously and use client acts every 100 message or 500 messages, whatever you like. From the publishing side, from the producer side, you need to use publish confirms if you care about your data. Again, you need to listen for what the cluster or the broker has to tell you, because if you're just blindly firing and publishing data, you just have no idea how far behind the mirror queues are, for example. And here, just quoting the RabbitMQ.com documentation, the client currently does not perform any internal buffering of such outgoing messages. It is an application developer's responsibility to keep track of such messages and republish them. Publishers need to keep track. Now, and you can see the shift here. We're actually pushing back the complexity on the applications a little bit. And so you could picture what it means for a developer that has been using a system like easily for a number of years, and suddenly you tell him, well, you're actually going to have to write a little bit more code. But it actually works out pretty well. Another one on developer one is still on the theme of listening back from the broker. Implement listeners. Implement confirm listeners so that you know that your message has made it to the broker or not. Implement return listener for unroutable messages. I've stopped counting how many times we've had teams coming to us and saying, oh, we've lost data. Well, no, you haven't lost data. You just sent a message with a voting key you just sent a message and the broker didn't know what to do with it. It didn't route it to any queue, didn't know what to do with it, just dropped it into the floor. So the broker didn't actually lose data. From a publisher standpoint, yes, it might seem that you lose data. But the worst part is if you don't implement the return listener, you have no idea. It's just going to, your messages are just going to go to /dev/null silently. Shutdown listeners, recovery listeners, especially in the case of a cluster where nodes going down and the node failures happen, you need to implement those if you want to have any kind of feedback. I'm going to go through deployment and management of the Rabbit estate at Goldman Sachs. So we quickly reached a scale where we could no longer install brokers and clusters manually and no longer fiddle with configurations and fine-tune things manually. So we actually had 2 generations of provisioning. The first one was pretty crude. We had a really simple configuration system, and then after maybe 20 or 25 clusters, this is when we decided, okay, like we have to do something now because RabbitMQ is picking up steam internally at Goldman Sachs, and a lot of developers want to use it, and we're not scaled as a messaging engineering team to deploy all of those. And you don't want to be a bottleneck. If people want to use it, if people want to use something because they find it's cool, you don't want to be in the middle and say, oh, sorry, like you're going to have to wait for a week for a cluster. So we built an automated provisioning system. We call it a resource manager. This is the way we deploy pretty much every messaging product at Goldman Sachs, be it RabbitMQ or anything else. We rely on something called JS App Engine. That's an internally developed software stack that allows us to efficiently deploy processes on hosts. So it's pretty simple, actually. You just have to fill in a JSON descriptor, and you can define, OK, I want to run this package on those hosts. And then JS App Engine will do everything for you. And so on the left, you can see that that's a farm of hosts. So we run virtual machines, and we run hundreds of them. And we run them in multiple regions, multiple data centers. We spread them across different hypervisors. And then we run one or multiple brokers per box. Our sort of default is usually 20 to 25 brokers per host. Sometimes if things get a little busy, then we reshuffle the rounds. And there's a whole sorts of placement engine associated with that. So what happens, let's say, if it's the first time that we're deploying a broker on a host that we just provisioned? Well, the host is going to start up, and he knows he actually runs a JS App Engine host agent that will query the JS App Engine backend and say, okay, what am I supposed to run? And JS App Engine will dictate, okay, you're supposed to run this. By this, actually, in our case, it's not right away a Rabbit broker. It's a bunch of wrappers that will then query our resource manager, and he understands that, okay, looks like I'm supposed to run a RabbitMQ broker. Looks that this broker is supposed to join a cluster. So it's going to query our inventory, which is backed by a database, and then it's going to reply with a whole lot of configurations and a lot of different tunables. And this is how we locally generate the RabbitMQ.config file with all the settings that we're supposed to run. And then the broker is going to join the cluster. Sometimes it can get a little bit racy with the cluster and the node discovery, something we are looking at improving with the new improvements in Rabbit 3.7. In terms of placement, we're also pretty careful. So if you were to ask for a 3-nodes cluster in a given data center, we make sure that the multiple brokers for a given cluster are not hosted on VMs that belong to the same hypervisor, because if you lose an underlying hypervisor and you lose the majority of the cluster, of course you lose availability, which completely defeats the purpose of clustering overall. It's a bit of a shame. So the automated provisioning system is exposed through a number of APIs. We also have a UI. So this is what it looks like. That's how the screenshot from our internal UI. So we can point and click create a Rabbit cluster. We can create what we call the connectivity. So that's to create the domain, the message domain I explained previously, and to create the users that go with it. We can actually reapply RabbitMQ configuration from inventory to the cluster. We can change any kind of Rabbit or Erlang runtime parameter. We can upgrade clusters. We can delete clusters, and so on and so on. config management. This is where you get into the nitty-gritty details of what does it mean to operate multiple clusters in automated fashion. While you arguably have a central inventory, you're supposed to know essentially what it is that you're running, where, and how. Now, creating an inventory document the first time is fairly easy. The first time you deploy a cluster, you know what's there. But then, what if I told you that people go and fiddle manually in the configuration? Never happens, right? Well, it does. It does. And so what your aim really should be when you operate things at scale is how do you minimize deviations? You need to make sure that what you have in inventory is actually what's deployed, because otherwise people are going to make assumptions, and this is where things go really bad. So what we do is we have continuous checks on inventory versus actual consistency. So before we make any change, let's say you want to add a user, you want to add a node or anything like that, or we want to upgrade the cluster. Before every order is fulfilled, before we even start touching the cluster, we actually check. We use the RabbitMQ API to pull down all the configuration, and we compare this with inventory. If there's anything different, then the request will fail. It doesn't fix it for you, but it nicely tells you that something is wrong, and in the later versions of this, we even have a list of what's wrong. We'll tell you, well, there's users A, B, and C in inventory, but there's only users A and B in the cluster. So you should probably fix that. And then you go and either manually use the RabbitMQ APIs to fix, add stuff on the cluster, or maybe it's stuff that is missing from the inventory, and then we would go and patch the inventory. Telemetry is your friend. I cannot insist enough on that. Don't fly blind. You want to know what's happening. We can't, as I said, we can't babysit every single blocker, every single cluster. So we collect metrics from the management API. Statistics are pretty neat in RabbitMQ, so we collect them every 30 seconds, I think. And then, so the management UI is really great, out of the box. I think it's something a lot of our developers use, and one of the reasons we really liked RabbitMQ in the first place. But a management interface can only store data for so long. So we then push this into an internal offering for time series. And we have automated dashboard generation, which I can show you now. So this is what a dashboard for a Rabbit cluster looks at Goldman Sachs. So you have system metrics, so for all the underlying hosts, cluster metrics, blocker metrics, queues, and cluster links as well to see where the data is flowing. This is all backed by the inventory. So if we were to add a node to a cluster, if we were to do any kind of changes, then this would be reflected automatically. You just have to refresh the dashboard. Queue metrics are really useful for developers because then automatically they can have a look at the trend of the last couple of days. And most importantly, a lot of those dashboards, a lot of those metrics, we don't really, as a messaging engineering team, we don't necessarily have a look at them too much because what does it mean that consumer utilization on application B and consumer 1 is 80% instead of 20% or the other way around? Well, we're not the best place to answer that question. And so this is really meant as a self-service. So application developers know, and the application operations team know where to go. And when they have an issue, they can straight up look at the dashboard and see what's happening. For any metric that we collect, they can also, in a self-service manner, set up any kind of alerting. So queue death, pending messages on the queue, maybe 50 messages on this queue is bad, maybe it's not so bad, I wouldn't know. So I don't want to be in the loop of putting this together. They just have to put their own rules. Consumer utilization, queue rate, message rates, and etc. This is all on their side. They can do whatever they want with it. So that's the good part of it. The bad part of it is that when they come to us, it usually means that something is wrong. Actually, there's we do a lot of filtering, so that's convenient. But then when they reach out to us, then this is now how we know that we're in trouble because we know that we really have to troubleshoot something that might be tricky. When things go wrong, I would like to know. I wish I could say that everything is all rainbows and lollipops and everyone is happy and etc. But it isn't. A couple of things. I think Larissa in her talk, really good talk by the way, highlighted a lot of anti-patterns. The most common ones for us, single queue workloads. So that's your typical use cases where an application asked for a cluster, they started using it for a year, even 2 years, and then it works, and they bought a single queue. And then Then they ring you and say, hey, can we have a bigger cluster? Or can we have a bigger host? Like, what do you mean a bigger cluster? Well, this thing is slow. Okay, but using a single queue, and a single queue is a single core. So even if I was to give you a 32 cores box, that's not going to help you. Even if I was to add nodes, that's not going to help you. So shard your data, consistent hashing exchange, sharding plugin, a lot of good stuff here that's been talked about previously. I think it's relatively easy now to shard your data. Of course, there's a lot of questions on ordering, etc., but those can be engineered. Second one, large amounts of pending messages. The classic, my consumer is slow, or my consumer is actually down, and there's a fast publisher. Memory usage. So the problem is not so much the memory usage itself. That you could engineer. You could say, okay, my broker needs 20 gigs of memory. Okay, fair enough. We can plan ahead for that. But the problem is the swing effect and unpredictable performance. Now, if you're latency sensitive, that's going to be an issue, because if you're publishing really fast and you've got slow consumers, then you're going to have this nasty swing where you're going to fill up the memory, and then you're going to hit the memory watermark, and then the broker will say, whoa, okay, can't keep up, need to swap out to disk. Whether messages are persistent or non-persistent, needs to swap out to disk. And then it's going to start throttling back the publisher, or even blocking it, and then the publisher suddenly goes, oh, okay, can't do anything. And then RabbitMQ will have paged everything needed to disk, and then we're back into memory, and then the publisher then resumes. And you've got, in terms of message rates, this gives you a nasty swing like that. We had in early days a lot of problems with that. Mostly good now with lazy queues. It's almost as fast as normal queues. Sometimes actually even faster depending on the payload on the workloads. And most importantly, it's predictable performance. Mostly predictable. When something is predictable, then it means that you can plan ahead, and then you can decide, okay, I need 1 queue, 5 queue, 10 queues, maybe I need multiple clusters, maybe I can shard across clusters, and then it means that you can plan ahead and design your application around all of this. Shutdown and startup order. I feel bad putting this, but being transparent, in a RabbitMQ cluster, the last node to go down should be the first node to go up. But when you deal with orchestration, if you're doing upgrades, if you're doing a rolling restart, like if you bring down the whole cluster, you have to be a little bit careful. And the way we were deploying and starting up brokers, sometimes we had issues with that. We wouldn't necessarily lose data, because a Rabbit broker will actually refuse to start if he realizes that you're starting it first and it wasn't the last one to go down. It's a bit annoying, because actually the broker would then crash, and then our automated process monitoring would then restart them over and over and over. I think it's much better now in 3.7. I'm happy to stand corrected, but I think now the broker is going to come up and then wait for the other ones, which sounds like a much nicer way of handling this. So where are we now? It's been quite a journey, 225 clusters, nothing in the thousands, I'm afraid. We serve about 170 applications. Some applications use one or multiple clusters. We run a mix of 366 and 316. I think we started out with 313. Then, we obviously don't go for every single version. I think we went for 313, then 330, then 350, 351, 357. We stayed quite a while in 357, actually. We still have a couple dead skeletons here and there, but it's probably like 0.5%. And then 366 and 3616. There's a lot of goodness in 3.7. We're actually starting engineering it now. So it's not going to be like a simple upgrade for us, because it's not just Rabbit per se, but it's the way we've designed our provisioning system means that we have to rework a lot of that and make it better, so that we can benefit from the new features from Rabbit 3.7. And for us, it's very important to certify versions beforehand, a lot of testing, because when it's out there, then of course we're on the hook for running this at scale. And we also usually don't like to have too much of a tail in upgrading. So once we've started certifying a version, then we go all in on it, and then we upgrade as fast as possible. We don't really like running multiple versions. So what's next? So I mentioned the automated provisioning. We're still to this stage. It's mostly our support teams, messaging support teams, or messaging engineering team that are pushing the buttons and hitting the APIs or hitting the UI. We would like this to be even more, a lot more service, where application developers can hit our APIs. But to do this, there's a lot of capacity management constraints, a lot of permissioning, and a lot of accountability and tracking that needs to be put in place. And we want to make sure that this thing is rock solid, because again, once you've put this out there, I mean, developers love API. If you give them an API that they can order stuff, they're going to order everything. I'm going to order like a 200 nodes cluster. I'm going to order 50 clusters, you know, in all regions. And so you sort of have to understand what makes sense. You don't want to be too dictating. You don't want to constrain developers too much. But you also have to be careful of what's your surface area and what you expose yourself as a team to. The next point, replication. So right now, we only run in data center clusters. We don't stretch clusters across data centers, let alone across regions. We don't use any kind of replication. We looked at federation but for Exchange or queues. But then it didn't really do what we wanted to, because then the consumers have to be smart. Ideally, we would want something that replicates data and consumers know exactly where they are, and there's actually state that is synchronized and acknowledgements that are fed back from both sides of replication. Ideally, we would like to stretch out clusters, but we can't because we use post-minority, and in most regions, we only have 2 data centers. So how do you achieve quorum with 2 data centers? Well, I'll let you do the math. So maybe something else, we'll see. Maybe quorum queue could help us here, I don't know. Sounds pretty promising. Last point, P discovery. So right now, our configuration is pretty static. So as I showed in a previous slide, we generate RabbitMQ.config templates using the provisioning system, but that means that the list of nodes in the cluster is static. So you have the cluster section using the Erlang syntax in the config file that lists explicitly all the nodes. We'd like to use something else, and that comes with 3.7. We'd like to use another repository. It could be TCD, it could be console, you name it. So looking at that, so it's much easier for us to register nodes. So I think that's it today for me. By the way, we're hiring, not necessarily my team directly, but I think we do a lot of cool stuff at scale, a lot of different products. So check it out. We've got a number of job openings. So yes, have a look. Thanks for having me, and yes, let's shoot for questions.
Thanks a lot, Jonathan. We already have some questions, so let's dig right into it.
Hi, thanks for the talk. On the theme of 80% of the problems are not actually with the broker, but with the client application, do you have any recommendations, or do you have any control over the APIs which client libraries teams use?
So, recommendation is all about object churn, don't have like queues that are too big, and etc. All the good stuff that has been exposed throughout today. I think in terms of APIs, so we've been in the business of doing wrappers around messaging products in the past, and that's what we had we had a wrapper named GMS, because Goldman Sachs would like to put GS in front of everything, and this was meant for developers to not hurt themselves too badly when using GMS wrappers. But the problem is then you get into the business of having to maintain that wrapper over time, and you have to do it across multiple languages, and so we're primarily a Java shop, at least historically. So for GMS, it was mostly Java. It was fine. But when you have a look at RabbitMQ, the number of bindings that are out there, language bindings and APIs, you're not going to be able to maintain that over time. So we would much rather have developers use whatever API they have at their disposal. We put together a number of best practices in terms and conditions. Some people read them. Some people don't read them. And then, yes, of course, we're on the hook when things go wrong. And of course, a lot of the times, it's on the application side. But hey.
Hi. How do you using the cluster upgrade, like patch version upgrade, rolling update, and minor and upper level update, like blue-green update? How do you achieve this upgrade scenario?
Sure. Well, we mostly, dependent on on how easy the core developers from the Rabbit team make it for us. So either if it's like minor and we can do rolling upgrade, then we do it, and our goal is always to have the cluster up and available as much as possible. If it's not possible, then I was actually pretty surprised that from 3.6.6 to 3.6.16 sounds to me like a minor version from a semantic point of view, but actually no, you need to shut down all the nodes on the cluster, do the upgrade, and bring them back up, which means that's loss of availability. Thankfully, a lot of our use cases are geared towards the financial markets, and financial markets, actually, most of them actually close over the weekend, so we can do that over the weekend.
At the beginning that under the previous set of tools you were using kind of had these polar extremes, and clearly it's working. You've got 170 applications. Can you give an example of like a use case or a type of workload that you've been able to better support now that you've adopted RabbitMQ?
I don't have a specific use case actually. It's all about I think the biggest takeaway is the high availability. And the fact that having a node going down is not much of an issue anymore. I think if we're still thinking about pure transactions and regulatory flows, we probably wouldn't be using RabbitMQ for those. We still rely on the guaranteed messaging stacks. But no really specific use case. As long as in terms of as long as Rabbit fits the bill in terms of volume and in terms of the consistency versus availability paradigm, as long as it fits the application, it could be any. It's more the volume and the workload itself rather than the use case.
Hi, thanks very much for the talk. You mentioned back in 2013 you were using multicast messaging, which you said is good for live ticking data. I was just wondering how well Rabbit has sort of replaced that and whether you still have multicast hanging around.
So I'll tell you how many applications Rabbit took out that were using this technology. Right, it's mostly the number of subscribers and the way we deploy clusters and the way that, let's be honest, in terms of message rates, it's multicast space is decentralized. It's just relying on a network to do the heavy lifting. If you're looking at a message broker, and that's not on Rabbit per se, it's because it's a broker. It has to do a lot of housekeeping, and it needs to maintain God knows how many TCP connections. So for the most part, it's mostly zero, right? Applications that were using multicast are still massively using multicast.
Thank you.
All right, let's do a final question. Going once. There we go.
Thanks for the talk. You mentioned that you kind of have a central messaging team that services all the other teams that have kind of 200-odd applications. If you make a change like a patch or some configuration change, how do you test that your change isn't going to cause a problem for one of the teams that kind of rely on the services you provide, I suppose?
Okay, well, that's a very, very good question. Of course, we do our internal testing, internal engineering, but we can't simulate every single workload in the firm, right? It's too many different applications, too many different use cases. So this is why we have non-production environments, and push the change. And if it's fine, then it means that it should be fine in production. If it's not fine in production, then it means as an application team, your non-production environment doesn't mimic or doesn't follow your production close enough, and then I'm going to have to kick it back to you.
Perfect. Thanks a lot. Let's thank Jonathan with an applause.